Can you hear me? Okay, let's get this. Is that any better? Okay. Yeah. I can't. I get closer to it. Okay. All right, so good afternoon, everybody. It's a real pleasure to be here and be surrounded by so many innovators. It's quite exciting. So I'm here to talk about something a little bit different to what we heard this morning. So topic is climate change, but really how smart IoT devices with really sophisticated controls can be a real part of the solution, help protect the planet, but at the same time make our homes more comfortable and save us money at the same time. So what's not to like about that? So when me and my co-founders founded the company a few years ago, the questions on our mind were, well, how can we help have an impact on climate change, but do it in a way that's going to be cost-effective, scalable, to really, make a difference? And also, how can we help our buildings stop using methane gas and transform to clean electric, but do that without destroying the electric grid? So out of those questions came Harvest Thermal, because we quickly became aware that there aren't any good solutions out there, and yet we knew that with some smart, streamlined engineering and some really good, sophisticated controls, we could really make a difference. So before I jump into what we're doing and how we're doing it, just a little bit of context. So first of all, many people might not know, but buildings represent about 1/3 of all emissions in the US today. That's as much as transport, and it's something we haven't really talked about much so far. But another thing that people aren't necessarily aware about is when we look at our buildings, how are we using energy? 2/3 of the energy that we use is actually for heating and and generating hot water for our homes. And most of that is by burning gas or fuel oil in furnaces, in boilers, in gas water heaters. And a lot of us are paying attention to, say, how we turn on our AC, how we use our dryer, how we use our lights. And we're even putting solar panels on our roofs, which is all good, but we're only addressing a small part of the pie. If you can just tackle your heating and hot water, you're good. You've really addressed the major part of the problem. In fact, in a growing number of cities and states and even countries around the world, people are trying to figure out how do we help homes transition away from gas. But when we're talking about gas in homes, it's not your stove that we're worried about. It's not your gas dryer. 90% of that is your heating and hot water. So again, tackle those two things and you're rosy, you've solved the problem. So, gas furnaces, gas boilers, they may not seem like appropriate topics for a conference on technology. And it's true, traditional devices are not technically smart. And I can say that my first devices before I started this company used to look like this. But that's changing. The new devices are sleeker, they're more streamlined, they're more efficient. In our case, they're also super smart. What that means is with these smarts, you can reduce your emissions, you can reduce your costs, you can increase your comfort, have high control, and do all that with any compromise. So what do we do? So Harvest Thermal has developed a product called the Pod, which I'm going to show. Oops, go back. Which you can see in the middle, and this is a smart, interconnected control. It's about the size of a large shoebox. It fits on the wall of your tank closet in your mechanical room, and it's the brains of the overall system. It contains physical controls, electronics, and our smart software. And that drives the whole system. It runs one high-performance heat pump at times of day where electricity is clean, cheap, and abundant. And heat pumps are fabulous devices. They move heat rather than generating it, so they're many times more efficient than even the best gas furnace. So the pod operates the heat pump and generates hot water at high temperatures, and then stores it in the tank. And the pod transformed that tank into a thermal battery. It's got about the same capacity as a Tesla Powerwall, storing up hot water, decoupling the time when you operate the heat pump, and delivering the heating and the hot water whenever you need it. And yes, we can also do cooling as well. People talk about, say, a Tesla vehicle as a computer on wheels. And we like to talk about the Harvest Pod as a computer on a tank. It really is very sophisticated, contains a lot of controls. For example, fluid mechanics algorithms, it connects with the grid to be able to respond to demand or curtailment requests. It tracks the weather and the weather forecast and adapts the performance based on what's coming, what the weather's going to be ahead. So it keeps your home warm, delivers your hot water, keeps you up to date with what's going on. How much money have you saved? How many emissions have you saved? And also you have that comfort and reassurance of predictive maintenance and predictive alerts, so you know that nothing's going to go wrong. In terms of machine learning, for example, the system learns how your home responds to, say, solar gain or outdoor temperature, and is able to adapt the algorithms and plan ahead, taking that into account. It gets to know how your family is going to respond and make sure that you always have enough hot water, enough heating, without wasting any. It also gives you high levels of control. I mentioned it's going to tell you what you're using, what you're saving. You can boost it when you've got guests coming. You can go on vacation mode. But most importantly, never again will you have your furnace failing and then you have to scramble to get a replacement so you still have heating and hot water. We give you predictive maintenance. You know ahead of time what's happening. You can do the maintenance without any trouble. Now, the proof is really in the performance, and the team is really proud of what we've achieved. So here you can see that compared to a standard gas furnace and hot water, it reduces emissions by 90%, and compared to heat pump systems, heating and hot water, it's reducing emissions by about 50 to 60%. So that's huge. But really importantly, it's always also saving money. Right, reducing bills by about 40% compared to gas, by about 30% compared to heat pumps. And that's really important because typically electric systems don't really save money. So it's the right thing to do, but it's really hard to make it pen out. Whereas here, it's not just the right thing to do for the planet, it's going to save you money. It's the best financial investment you can make. Most importantly, it's super comfortable. In fact, I used to have an oil gas furnace and I was used to it, but once I transitioned to this type of solution, it's just way more comfortable. And our customers are saying the same thing. It's super quiet, it's super stable. No, it's not drafty, it's just nice to live with. Now, I've talked a bit about what we do and what the results are, but I wanted to build an intuition about why it works. So here you can see, this is the 24 hours, the average 24 hours in the life of a grid provider. And you can see how the emissions from the grid are much higher in the morning and the evening than they are in the middle of the day. And that's because in the middle of the day, we've got increasing amounts of solar in the grid, whether from rooftop or from utility scale solar. And also in the morning and the evening, that's when it's most expensive to generate electricity. You've got to ramp up those gas peaker plants. That costs a lot of money. So this is the shape of the typical duct curve that some of you may be familiar with. The belly in the middle of the day, that's when it's cheaper and cleaner. Now, the challenge is we're saying to people, okay, let's stop using gas in our home. Let's try and, fight this climate change. Let's reduce our emissions. The problem is heating is very time dependent. You need your heating in the morning and the evening, not so much in the middle of the day. So that is the right thing to do, but it's a challenge for the utilities. Wouldn't it be nice if your heating load could be in the shape of an upside down duck? That's exactly what the Harvest system delivers automatically. Using just one tank and one heat pump, we shift that load to the middle of the day, but deliver your heating and hot water whenever you need it. And that's why we deliver cheapest electricity, why it's extremely comfortable, and why we can meet the needs of our utilities and our grids. So I'm going to geek out just a little bit, just to go under the hood for those who have an engineering background, who want to understand a little bit about the why. The orange curve here is showing on the coldest day of the year in our target market in Northern California, what the heating load looks like. And you can see a huge spike in the morning and a lot less during the rest of the day. So when you install a furnace or when you install a heat pump, it has to be sized for the coldest hour of the year, even if it's only going to be used for a few hours at the time. Now, Harvest Thermal, by decoupling the heat pump from the heating delivery, we have to meet the blue line. We have to meet the coldest day of the year. And you can see that's typically 2 or 3 times less. That means that with just a 1.25 ton heat pump, we can easily meet the load of a 3,000 square foot home with 6 people. In fact, we've been doing that for the past 2 winters. So it really optimizes not just the bills, but also the equipment that you need to install the system. And another thing I've mentioned a few times, efficiency. Again, all the smart controls we have really allow us to optimize for efficiency. You optimize heat pumps are much more efficient when it's warm. But if you want to put your heating on in the morning, typically you're going to have to run your heat pump at 5 a.m., 6 a.m. It's not typically warm. We're able to choose when to run that heat pump. Our controls are going to schedule ahead of time to meet your need, but also take into account the weather forecast and optimize when you should really optimize that, run that heat pump. And so we're able to shift it. We're gaining 10, 15% in terms of efficiency by being able to shift the time of operation of the heat pump to the warmest times of the day. So here's the system. It delivers lower energy bills, much more streamlined equipment, just one heat pump, one tank, no need for a Tesla Powerwall, and you get the same performance. And it also supports the electricity grid. Now, this is an area in complete transformation, I'd say in complete disruption, right? There is a growing awareness that we're facing challenges. In my home state of California, we now have a smoke season in September. You can't go out because it's smoky. And a lot of people are seeing changes around where they're living. And so cities, states, countries even, UK, Germany, Australia, many states in the US are trying to figure out how to fight it. And it's driven by homeowners. They want to optimize their costs. They want high comfort homes. They want to control the system, but increasingly they're concerned about carbon. We've got the builders who are grappling with increasingly stringent regulations and new building code to help transform the behavior. And then, of course, the grids and the utilities who are trying to drive change because they have to reduce emissions. For example, current systems that we're deploying in California, yes, they're saving money on the bills, so they make a lot of sense economically already. But today, they're receiving $7,000 for every system installed. And in 2023, they'll be getting $10,000 for every system installed. This is because of the value that this brings and the urgency to be able to change out the systems with newer, cleaner, more comfortable devices. So the market is big. We're talking of 8 million systems replaced every year just in areas with strong regulations to try and change what we're doing. And that, opens the door for a huge market opportunity. The systems are deployed in existing homes. You can retrofit it, but they're also deployed in new homes. So we're working with new builders to try and see how can we put the right systems in place as homes are built rather than waiting to retrofit them later. Sorry. And really importantly, we're also delivering grid services. We respond to the grid if they have a need to curtail electricity, if they need to change the load. It's very easy for us to shift the demand to different times of the day. And that generates the opportunity for demand response and revenue, both for the homeowners and for the utilities. Now, we founded the company back in 2019. We've had pilots in place before that for the last 4 years, and we've been getting some of the results I've been sharing with you. We launched commercially in January this year, and here are some of the new homeowners and some of our team and some of the systems being put in place. And here you can see some of the contractors we're partnered with. We now have 30+ contractors who are trained on our system to deploy our system, currently starting in the California Bay Area, but we're looking to expand over the coming months and year. Thank you very much. I look forward to your questions.
Okay. This is very interesting. Can you go in a little more in depth in retrofitting existing homes? Does it only work with forced air conduits, or can it also be used by radiant heat that uses hot water circulating through the home?
That's a great question, and thank you for asking it. So we try and be as independent as possible. So we're really at the back end, we supply the heat. And so we've currently deployed both in homes with forced air, but also in homes with radiant floor. And there's no reason why we can't expand that beyond that to heated baseboards and to the European-style radiators. We supply the hot water. It can be forced air, it can be radiant floor, or other systems. We want to be as flexible as possible.
I'm sorry I missed the first half. So did you talk about cost versus what's already out there and the investment of the homeowner / builder?
Yeah, absolutely. I mean, cost has been a key part of it. You know, when we founded the company, it was founded on the premise that I had an aging gas furnace, and I didn't want to replace it with another one because, you know, I wanted something cleaner, I wanted something smarter, and I looked at what was on the market, and I would have had to have a heat pump for my space conditioning, a heat pump for my hot water. If I wanted to use solar electricity, I would have needed an electrochemical battery like a Tesla Powerwall to shift the load, and I just couldn't afford it. And I also was aware that many other people wouldn't be able to afford it as well. So that's why we streamlined the system. So first of all, from an infrastructure perspective, we're talking about just one heat pump, not two. Your tank, a standard tank, is just an active storage tank, and then our pod delivers all your heating and hot water. So already today, it's more cost-effective than electric alternatives that you put in space. It is also reducing bills. So the bills compared to gas are down by about 40%, compared to electric heat pumps down by about 25 to 30%. So, you know, month over month, you know, year over year, you're saving money. Now, the upfront cost is somewhat more expensive than putting in a gas furnace, but it definitely does give you payback. In fact, the payback comes quicker than it would for a solar panel system. And in many of the places where we're currently working, you know, we're targeting areas which are determined and focused on how can we help people make this transition. And so there are incentives. So, you know, we know that for people deploying in our current target markets, over the lifetime of the system is going to pay back about $18,000 to $20,000 compared to having a gas system. So it does make a lot of sense financially.
Hi, can you talk about, like a lot of homes now have tankless water heaters and they're kind of going away, like trying to go to tankless or, you know, no actual physical space being taken up. Can you talk a little bit about that? And then also in the areas where cooling is more important than heating?
Yeah, absolutely. So I'll start with the cooling question. First of all, our systems are currently compatible with cooling. And so we're deploying right now systems with cooling as well. What I'd like to get to, and we will do over the next year or so, is have an integrated system where we have a single heat pump that delivers the cooling, and why not also storage for the cooling so you can do load shifting with cooling. So right now what we're doing is we're helping people get off gas, reduce their bills, really slash those emissions, and not depriving them of cooling. But I want to go to the next level and also allow the load shifting for the cooling as well. We're not quite there, but we can still deliver the cooling to your home. And the other question was? Tankless, yeah. So there've been a growing number of tankless people with tankless water heaters, and they tend to be either gas or electric resistance. And the challenge with that is electric resistance is really poor efficiency, and the gas, well, you know, that's fine, but that's increasingly going to be phased out over the coming years. So I think what happens right now is, you know, we're deploying in homes where you can put a tank either in a tank closet or in a garage, because the tank is your battery. And so it's the most cost-effective battery there is. You know, electrochemical batteries are great for electric loads, but they're really not good at storing thermal energy. A tank is the most cost-effective, safest, and durable way to store thermal energy. So that really is a key part of the puzzle. So we're working with people to figure out where can we put it. And in some cases, people have built a little shed outside their house, and they put the tank in there because they didn't have quite space in their home anymore. And so we're working with people, smaller tanks you can put side by side, to make sure that the whole system's going to work for you. You're welcome.
Do you think this could scale to like the industrial level, like take the same approach but maybe apply it to power plants or other sources which are, you know, polluting? Could we optimize certain processes like we do here?
So we're really focused on distributed buildings, right? Because there are just millions of them and they last a long time. They're all going to be there in 2050, and we need to figure out how to progressively transition them. We could certainly apply this solution to, say, small commercial or even apartment buildings. And thermal storage, I know, works for large commercial buildings as well. As a small company, I know many of the innovators in the room may understand what I'm going to say is we need to focus. There is a huge need and a huge lack of solutions in the home market, also in small commercial market, and that's where we're really going to focus. Now, over time, could this technology be expanded by ourselves, or why not by other people to a broader market? Absolutely. But right now we're focusing on the homes. Okay, well, thank you very much for your questions, your attention.